two,
Okay.
three, and when you're ready.
1, 2, 3. Ready.
Okay.
Ready.
Okay, so I'm here with Fernando Martirena
Yes.
from Cuba.
Yes.
Tell us, first of all, what you currently do.
Well, I'm a professor at the Universidad Central de las Villas in Cuba.
Okay.
This is the second university in the country.
Yeah.
And in there I am the head of the research center called CEDEM, Center for Research and Development of Structures and Materials.
Structures and materials. But you didn't start like that. I think you were once a rocket scientist, so tell us about that.
Well, before the crisis, Cuba was, in its way, was a developed country. I mean, you could take a plane and go to Europe and Moscow and East Europe. You could do whatever you like. But then when we faced the crisis, our lives completely changed. Before the crisis, I used to work on computer modeling of structures. So I used to work in a program with Russian, rocket scientists on developing a global communication system so my role was to develop antennas, parabolic antennas.
Parabolic antennas. Okay, but for an Australian audience that may not even understand what the crisis is, so what happened? Suddenly the Soviet Union kind of imploded.
Well,
and then
East Europe for us was the market,
Yes.
was the international market.
Yeah.
We lost overnight, almost overnight, we lost 75% of our market.
Wow.
Can you imagine?
So all of your products and services, and apparently also you lost oil
Yeah.
and fertilizers.
Yeah, we had 13 million tons of oil per year supplied from East Europe, from Russia, basically, and it dropped down in a question of months. It dropped down to 4,000 million
so
tons.
what does the rocket scientist do when suddenly his
Well,
mission is...
I was prompted to do something to
Yes.
find out a solution. So
Yes.
how you can work in this condition of isolation.
Yeah.
This is how I came across to the sustainable practices, and this is how I first heard the word sustainability.
Okay, and so now let's fast forward. What year was that, the crisis?
That was 1991.
1991. So here we are in 2013, and from what I understand, you now are basically allowing construction to happen for homes and businesses at a very, very local level, using exactly what is locally available.
Exactly.
But not only are you doing that, drawing on the technologies, practices, and materials that are locally there, you've connected with the Swiss government, some of the world's largest multinationals, the engineering community, and this incredible scientific research capacity. And how does that combination work?
Well, because first of all, we grew up in the idea of small is beautiful. So that was a very interesting idea. There's this interesting book by Fritz Schumacher, and it's very compelling when you realize that you have so many resources. Just at you only have to stretch out your hand to touch them.
And when that's all you have, you suddenly become aware of what they are.
Exactly. And so we developed things, but there was a point we realized we cannot improvise. So being a scientist myself, I realized you have to make science in that. So you have to really get deep into a process. And we started to implement what you would call the innovation loop. So you start in fundamental science, then you do applied research, then you develop machinery, then you implement it at the local scale, and then you feed back again to the fundamental
and what
science.
you're talking about here is building homes from cement that can be recompacted, whatever is there, hay, dirt, mud.
We have two main principles.
Yeah.
The first one is you try to lower energy, the energy input in materials. And the main share of energy is transport. So provided you are local, whatever you use, you are reducing a huge amount of energy, then you're reducing energy in materials.
Okay.
And the second point is wherever you can, recycle. Because when you recycle the material, you're using a former life of the material. And an energy that is already used in the material. So you're saving energy at the same time.
Fantastic.
So basically this is the concept.
Okay, so before we were talking about how there's quite a bit of embedded toxins when you break down things that have been there for some time with paints and everything else. And yet to get around the regulations of that, to keep things safe from a kind of toxic waste point of view, you're working with European companies that have developed intellectual property and how you encase that. So how does that work?
Well, it's very important because you have to access the knowledge. and the knowledge is there. So you approach these people, and these people are willing to cooperate with you, and we develop ideas together. They have developed this technology for lightweight aggregate, so they encapsulate the material and make it less porous.
Yes.
And we have the same problems in recycled aggregates. So we say, okay, can we do this for recycled aggregates? And there's in the common in the industry and the community, scientific community, there are many people against recycling aggregates because they lose their properties.
Right.
We tried that; it worked very well. And now, you know,
it's a bit like Michael Reynolds and his Earth ships, and they work very well.
Exactly.
Regulators don't like them, planners don't like them, you know.
But you know, there's some pioneering enterprises that are already interested.
That are ready to go.
There are machine manufacturers that already are calling us, and this is
European, German, large-scale
and Italian,
Italians.
Once you get them on board, the whole thing goes on alone. You know, it's like a thread. You know.
Okay. And so apparently you have graduated 15 PhDs.
Yes, in the last 7 years.
In the last 7 years, who have the technical capacity to scale this work at a very local.
They're basically, you know, leaders.
Yeah.
I have to say, 40% are female.
That was the right thing to say.
I love to work with females. I mean, they're really engaged in the issue.
Women are
you
pretty
can
good,
you can work with women so well, and I really love that.
Okay,
I mean, at the moment, I have even more. I have 60% who are female.
Wow.
So men start to complain.
Yeah, of course. You do get jealous when you recognize talent.
Yeah.
Okay, now the very last thing. You were telling me about the system of technology transfer that exists between Cuba, Ecuador, Paraguay, Mexico, all over the Americas. How does that work?
Well, the main stumbling block when you think about really transferring that technology to the grassroots is the high cost of the professional fees of the experts.
Yeah.
There are many experts in Europe, probably here as well in North America. But then when you think about bringing this expert to a South American country, it becomes a bit of a burden. Well, we have realized once we identify a local, somebody, a brick maker in Nicaragua, who's making something that is really innovative, we want to transfer it to Cuba. It's very easy. We just pay the flight ticket. Somebody in Cuba will host that person, and will provide him food and everything and an environment. He is able to transfer the technology. So we call it BBB. So bed. He needs a bed. He needs some bread, that means some food, and he needs some beer as well. So,
Casa, Comida y Cerveza. Por supuesto.
And through that practice, we've been able to, share a lot because once it is in Cuba, it is further disseminated through all the regions using the same concept.
Okay, so Fernando is hereby appointed a Green Cross Australia Ambassador at Large.
Thank you very much.
May your ideas spread around the world. It's wonderful to meet you.
Thank you very much.
Thank you
I'm
for
glad
sharing your
to be.
thoughts. Fantastic.
Thank you.